stop there because my downstairs is the same thing. So there's no point in me going further. I can cancel those things out. All right, is everybody okay? All right, the next concept, which is summation. Okay, I can't emphasize enough how important this concept is, because when you come back next year as a senior in calculus in September, you're going to start out with this notation. That's the very first thing that you're going to do, okay, within the first week or two. Okay, so you really want to pay attention to this section, because we use ideas from here again next year and throughout the year, as a matter of fact. Throughout the year next year. So what I want to do is I want to show you how to write this thing here in shorthand form. Okay, in shorthand form. So notice that this is really a series. Yesterday I defined to you what a sequence was. Does anybody remember what a sequence is? What is a sequence? Sorry? A set of numbers that have a pattern, exactly. Okay? This is actually called a series, and we'll see this definition again in a minute. It's called a series. A series is nothing more than a sum of a sequence. Okay? So a sequence is a bunch of numbers. A series is just a sum of those numbers. That's all it means. Okay? It's some pattern on it. So you know that the sequence is made up of 1, 2, 3, so on, all the way up to 100. So can someone give me the formula for a sub n? Remember, a sub n just means the nth number in that sequence. What do you think it's going to be? What's it going to be? What's it going to be, people? Whoa. Yeah, Leila? In functional form, okay, in functional form. Sorry? It's just n. It's just n. All right? It's just n. Because if n is 1, you get that. If n is 2, you get that. If n is 3, you get that. So you can actually write this thing, 1 plus 2 plus 3, and so on, plus 100, as sigma. N starts out with 1, goes up to 100, and that becomes n. Okay? That becomes n. So in other words, this is the shorthand form for writing 1 plus 2 plus 3 all the way up to 100. Okay, all the way up to 100. Let's leave it there. Okay, is everybody all right on this?
1 second.
So the way you read this is sigma n. N starts from 1, goes up to 100. That's how you read it. Sigma n, n equals 1 to 100.
Wait, so if n was 2, it'd be 2 to 100.
If n was what?
So n is just the starting point of the...
No, n is not the starting point. N is the variable of the sequence. Remember yesterday we learned about how to write a sequence in functional form?
Oh, just the number between each of them.
Yeah, it's called the index. You will see that in a minute.
Wait,
Okay.
how do you know the starting point?
I give it to you, right? It's right there. It's right there.
So if you had a starting point of 3 and the n is equal to 3?
No, then the sequence would be different, right? Wouldn't the sequence be n plus 2? If you're starting out at 3, okay, and you're going 3, 4, 5, 6, 7, and so on, what's the sequence for this? Isn't it just n plus 2? Yeah, so instead of this n, it would be n plus 2.
Oh.
N would still start at 1.
Okay.
Yes, n would still start at 1. It's a question of how you write the sequence. So yesterday you had a lot of practice writing the sequence. Okay, today we're going to see what we do with the sequence. Okay, how we add things together. Everybody okay on the sigma notation so far? Okay. Here's a lot of abstract looking math. You want to get this down because all the terms in here, all the jargon, all the terminology, you will need in calculus next year. So this guy here, that's called the lower limit. And this guy here is called the upper limit. Kind of obvious, isn't it? One is at the lower end of the sigma and the other one's at the upper end of the sigma. So kind of pretty obvious. You got to know that, okay? All right? And again, like I'm telling you, you're going to see a lot of this in calculus. So let me explain what this means in this context here. Okay, we now have an example where we can actually talk about numbers and what it really means. Okay, so get that down. Yeah, in this case, so, you know, it's just a variable. Okay, it's just a variable. Sorry? Do you want to wait or you want to go now? Because I have a lot to teach, so it's your choice. Yes, we will have time at the end. Okay, everybody get this down? Okay, can I start explaining this stuff? All right, so what does this mean, okay? So you're going to start out with k equals 1, so it would give you 1 plus 1 squared. Does everybody see that? Okay, started out with k equals 1, and so I get 1 plus 1 squared. So everybody with me on that? The next one is going to be 1 plus 2 squared. Everybody see that? And then the one after that, Keith? 3 squared. And Chris, the one after that? 1 plus 4 squared. And Ashna after that? 1 plus 5 squared. Okay, that's all this fancy thing means. Okay, and after that, you guys know how to do this. Okay, this is 1 plus 1 plus 1 plus 4 plus 1 plus 9 and so on. Okay, and so on. So all I'm saying is that this is a shorthand form for this, for that. Okay, some fancy math way of writing it. 3 squared. 3 squared be 9. At least in my book it'd be 9. Okay, so everybody okay, all right? Okay, next topic is a couple of properties of sums. Again, I'm going to emphasize to you that you really want to pay close attention to this stuff and really feel the math in there, because you're going to need this in calculus the very first week that you come into calculus. Okay, and you keep using these concepts over and over again. Okay, keep using these concepts over and over again.